Okay, this is a video for the last example in section, what is this, 8.3 trig substitution. And if you can solve this antiderivative with trig substitution, you've definitely got it all down. And I want to thank you guys today, watching you trying to go from that right triangle to that expression in that denominator we were trying to get to. And watching you all work together, that was amazing. And that's the way I want to see you guys work while I'm gone for this next couple of weeks to get through this chapter 8 stuff. All right. And I will do my best to be able to put a video up as Malcolm needs them. So let's get started on this problem right here. Now, when you first look at this problem, it does not look like it's formatted for trig substitution at all, because you're looking for one of these radicals right here, all right? Or at least what is underneath each of these radicals. And I don't see an a squared minus x squared. I don't see an a squared plus x squared, nor do I see an x squared minus a squared. So at first you got to be thinking, man, I don't know. But then if you go back to pre-calculus, hey, could we write x squared minus 6x plus 11 as a perfect square trinomial that we could factor plus another number? I believe we can. So I think we might get this to the a squared plus b squared that's underneath that radical right there. Okay, and that would lead to one of these three triangles. Triangle 1, triangle 2, triangle 3. And triangle 2 has the a squared plus x squared, so that's going to be our triangle right there. All right, so let's go ahead and start rewriting this triangle in terms of a. What do we have for a? So you look at this right off the bat and you're saying, hang on, hold on, where's my a? I don't see it right now. So let's find a perfect square of x squared minus 6x. Let's make x squared minus 6x a perfect square trinomial. All right, so we're just going to have to clean this up a little bit to get there. So, do you guys agree that half of negative 6 is negative 3, and if I square that, I get a positive 9? This is a perfect square trinomial by completing the square, and now I have to make that the equivalent of x squared minus 6x plus 11, so I'm just going to add 2 to this. Now let's write this expression in factored form. So x squared minus 6x plus 9 is x minus 3 quantity squared. And there I have my x squared plus 2, which I'm looking for right here as an x squared plus a squared. That's going to work. And that's going to make my triangle here in terms of x and my a. Well, opposite's going to be that x minus 3, because that's usually just the x right there. And my a is going to be, well, that's a squared, so a is going to be root 2. And then the radical is going to be the hypotenuse this time. And what's underneath that radical? X minus 3 quantity squared plus 2. Now we're ready to go to business right now, and I'm really excited. All right, so let's do our trig substitution, shall we? All right, well, I don't know why I rewrote that there, but let's rewrite this with our divisor in this form right here. So I'm going to go the differential of x and the x squared minus 6x plus 11, that quantity we're going to write as x minus 3 quantity squared plus 2. Okay, trig substitution time right now. All right, so what are we going to do? How are we going to go about doing this? And this is where we hit the wall right at the end of class today. And you guys were working so hard to get there. All right, and what we were trying to do is use the triangle, which we can do. All right, so I'm going to think, I'm going to start with that differential of x up top. So if x is, what's my a again? Root 2 tangent of theta, then wouldn't the differential of x be root 2 times the derivative of tangent of theta, which is secant squared theta? And then to make that a differential of x, we need a differential of theta. And now here we are. What is this? Let's go to the triangle up here. Do you see that alpha right there? And this was where I became really excited today, right at the end of the class. Kaylin, one of our sophomores in AP Calculus, was pointing at this right here, a secant of theta, all right? And we were trying to use the triangle to get there, all right? And we couldn't see it. But if you look at this triangle right now, do you agree secant of that angle theta would have to equal that radical over root 2? So, implies secant of theta equals radical x minus 3 quantity squared plus 2 over root 2. All right? And that leads to that radical would equal, multiply both sides by root 2, and we get root 2 secant of theta. A secant of theta. Root 2 secant of theta. By the way, this could give you a little bit of a shortcut, all right, for the other problems that we already did, but using the triangle leads to a lot greater understanding. But do what you need to do. So what we're saying right here is if the square root of a squared plus x squared is root 2 secant of theta, all right, and that means I just have the x squared plus a squared right there, so I have to square that. Root 2 squared is 2, secant theta squared is secant squared theta, so I've got a 2 secant squared theta. Now let's clean that up a little bit. So that's going to be what? 4 secant to the 4th theta? All right. And now let's clean that up. Hey, it looks like, okay, I could bring out a root 2 over 4, which I'm going to simplify a little bit. You don't have to, and write that as 1 over 2 root 2. All right. And then I have a secant squared over secant to the 4th. That would be 1 over secant squared. And isn't, with our reciprocal relationships, 1 over secant squared going to equal cosquared? Let's see if I went right to the cosquared. Yes, I did. And then my differential of theta right there. Okay? And there we have it. And now, don't we have a rule for the antiderivative of cosquared that we developed in 8.2? So, let's go. What are we going to start with? Isn't this going to be my theta over 2, and then 1/2 cosine of theta times sine theta, and then you got to have a plus c in there somewhere. Plus c, there it is. And I don't care if you put the c within the parenthesis or outside of the parenthesis. That does not matter. All right? And we could probably clean that up a little bit more. So all I'm going to do is each term has a divisor of 2. I'm going to bring that out. And I'm going to go, okay, this is 1 over 4 root 2. And then this term's going to be theta. All right? And I can use my calculator again because theta, let's see my triangle. Do you see this right here? Okay, and that was root 2 tangent of theta. So I'm going to write this theta in terms of tangent. And do you agree that tangent of theta is x minus 3 over root 2? So theta would be inverse tangent of the quantity x minus 3 over root 2. You take care, Doug. I'll see you in a few weeks. And there that is right there. All right. Now, we already pulled the 1/2 out. So same triangle. What is cosine of theta? And that would be a root 2 over root x minus 3 squared plus 2. Bam. And then sine of theta, well, that's going to be quantity x minus 3 over that radical right there. And then our plus c right there. All right. Now look at us. We have everything in terms of x right now. So we're essentially done. We could do a little cleanup if you guys want. All right. So let's see if we can clean it up. Now, Malcolm, you're probably sitting there going, hey, leave it there. But again, let's pretend it's multiple choice. We need a different form of the answer. So, well, I probably just multiplied these two fractions. How about root 2 times the quantity x minus 3? And same radical times same radical becomes x minus 3 quantity squared plus 2. All right. And now, well, what could I do with that? I'm going to go back to our original problem. See this x minus 3 quantity squared plus 2? Well, let's go. Distribute this, so I've got 1 over 4 root 2 times inverse tangent of x minus 3 over root 2. And then I've got a 1 over 4 root 2 times root 2, so the root 2's cancel, and I'm going to have the 1/4, And then I have the factor of x minus 3 up top still right there. And then, how am I going to write x minus 3 quantity squared plus 2? I'm going to go back to our original x squared minus 6x plus 11. And my friends, I think that is our final answer. Isn't that a cool problem? And I want to thank you all for the way you worked on that today in class. And again, you know, I was calling this triangle right here the keymaster all day. But Kaylin, you pointed out in this problem, that really led us to our solution right there. So now, you guys have some work time on both 8.2 and 8.3 while I'm gone, all right? And you get as many of these problems done. Make sure you understand this stuff because you are doing advanced calculus right now. In fact, you're doing advanced calculus right now. And if you go that direction, math's going to be very easy for you with the tools you walk out of Black Hills High School with. All right? So it's been a pleasure. I will try to keep videos updated, Malcolm. So I think we have 3 more sections. Depending how I recover after tomorrow, I will be doing probably a section a day as a video if my stuff's working out. And you just keep me posted on where you're at in Google Classroom. And remember, we're pacing on you and the classroom. We are not pacing on what I have in Google Classroom right now. Thank you, guys. I'm going to miss you, and I'll see you soon.